Welcome everybody to Everyday Engineering Virtual Apprenticeship lesson. This is the next lesson for the virtual apprenticeships. Um, so what we'll be learning today is about heat. Um, and before I go on, I just want to remind you all that here at Citizen Schools, we all do care about you, and be sure to talk with any one of us if you ever need anything. You can talk to us through our emails, or you can just send us a comment through Google Classroom or anything like that if you just want to keep up with your sister school teachers. Okay, now on to the lesson about heat. So what is heat? Heat is the transfer of kinetic energy from one medium or object to another, or from an energy source to to an object, such as energy transfer can occur in three ways: radiation, conduction, and convection. Don't worry, class, we'll go over these things. So first, I have something that you should wonder about. So if you leave a hot drink on a table and wait a while, does the drink heat up or cool off? If you leave a cold drink on the same table and wait a while, does the drink heat up or cool off? So I'm going to give you a couple of seconds to think about that. So you can, so this should be enough time, but pause if you don't know what the answers are. So if you leave a hot drink up, it won't heat up. It will cool off because it's already very warm. On the opposite, for a cold drink, it will heat up because the longer it's there, the colder it's getting. The ice is melting, it's heating up, and it's melting the ice and all that. So next thing we're talking about is thermal energy. The atoms inside of everything are always jiggling and bouncing around. If you remember from our solids and liquids and gases thing, all the atoms are always moving and stuff like that. So this connects. A thermometer can measure this kinetic energy and tell us temperature of something. The more jiggling, the higher the temperature. So if you see this uh, with cold water, right here, and then with hot water. So for a more visual approach, you can picture a steaming mug of coffee. Now picture a bathtub filled with the same steaming coffee. The temperature is the same, but the thermal energy is higher in the tub because there is more coffee. All right. So next, heat. Energy flows downhill. When you ski, you go down, not up. So thermal energy does the same thing. It flows down a temperature hill. Flowing thermal energy is called heat. Heat always flows from hot to cold. For example, heat always flows from hot to cold. So for your coffee, the heat that you're feeling is coming up, up towards the air, the cold room air. All right. Another heat example: if you're holding an ice cream cone in room temperature air, how does the heat flow between the ice cream hand and air? All right. So you see this. Your hand, which has a lot of heat, is moving towards the cold right here, and this is the room air moving down here too. So the ice cream's heat is at 32 Fahrenheit. The room temperature is 77, and the body temperature of your hand is 96 because it's so warm. Your body heat then transfers to the cold air over here, as an example. All right, moving on. Heat transfer. What does it mean to transfer something? In this case, we're talking about the movement of thermal energy. Three types of heat transfer, as I mentioned before, are conduction, convection, and radiation. No matter what type of heat transfer, it always flows from hot to cold. So here's another thought experiment that I'll read out loud, and then I'll give you a couple seconds, or you can pause to think about. So how would your hands feel if you held a bowl of hot soup? How would your hands feel if you're holding a snowball? And then remember, what would happen if you touched an object that is the same temperature as your hand? Would any heat transfer happen? Remember the ice cream. Okay, that should be enough time. If not, you can always pause. Um, so if you were touching a hot bowl of soup, the heat itself would be from the bowl would be transferring to your hands, and that's why you're feeling that hot sensation. In For the snowball, your hands are transferring the heat towards the very cold snowball, and then if you were touching something that was about the same temperature as your hand, no heat transfer would happen because it's both the same. All right, conduction. Conduction is heat transfer within or between solid objects, as you see here. So, can you think of some other examples? Like here, where the solid object of the heat transfer is from making iron, and you heat up iron really to a really hot temperature, and then you start hammering it so you can start shaping it. I'm gonna give you about 5 seconds to think about any other types of conduction you can think about. All right. And then more heat transfer on a hot summer day. Would you feel cooler if you stood under a fan? Why? That's another idea. All right. Moving on. Convection is the next idea we're talking about. Convection is heat transfer into or out of moving fluids. And so so the sun, right? No air exists between the earth and the sun, so how does solar energy get to the earth to keep us warm? The answer is little packets of energy called photons zip through space, bringing sun energy to the earth, keeping us all warm and alive. Radiation, it's warm air. So if you see conduction's about solids, con- convection is all about fluids. So radiation is all about how warm air rises or gases. So how does the thermal energy get to you're standing below this heater? Think about that. This heater right here. How does the thermal energy get to you when you're standing below it? Radiation is heat transfer due to packets of energy that can travel through many substances, including empty space. Most heat transfer occurs from radiation at high temperatures, like the flame in this patio heater. And just think about this type of radiation won't make you into the Spider-Man or the Hulk. Most radiation other is sometimes in high amounts is very dangerous. And then we have insulation. Insulation is a material that slows heat transfer. So you can think of your hydro flask and all that. So the heat doesn't transfer out; it's keeping it inside, so the temperature stays the same whether hot or cold. And then so that is the end of our heat lesson. But before I go, I do want to show you a couple cool activities you can do at home. And I'll provide the links on the detail on the information screen. But we have 3 activities that you can do at home that all relate to heat. One is making your own Slurpee. This seems super fun, and I felt that it would be a great little fun science project that you can do at home. So if my computer lets me, I'll show you. But here it will give you all the instructions to how to do this on your own. And you all want to or are confused about it and leave some comments, I will do a demonstration video on how to do this specific thing. But if you see with the science, you can make your own Slurpee and don't even have to go outside to the 7-Eleven. So it would be better for everybody. So here are all the instructions that you can check out. It'll give you step by step making your own flavor of Slurpee. The next fun activity is you can make your own color changing Play-Doh. As I know all you like playing with slime and all that, you can do a little fun product and make your own Play-Doh. Not like slime, but still something fun you can do. Keep yourselves occupied. Like saying, has all the instructions and all that. And if you comment and if you guys want to actually in-depth video of me showing you how to make it, just leave a couple comments. And if there's interest, I'll do it and show you. And then this one seems super interesting, and it would be super awesome if you guys can do some recordings and send it to us at Citizen Schools about you crushing a bottle with your own mind. Yeah, totally possible. And totally possible with science. So, if you follow these steps, you can do it. Alright? So, thank you everybody. Have a great day. Please like and comment on these videos. We're trying very hard to make these fun, and I'm trying to find little projects for you all to do that are also just as fun. Alright, class. Thank you. See you next time for an everyday engineering virtual lesson.